Welcome to the last lecture on new material for the semester. Sad to see it go in some ways, but man, I'm ready to see you guys face to face. So, hope things are going well. Take care. Here we go. So when we talk about weathering, that's one of the key things for the formation of soil from rocks. We've got a couple of key parts. One is mechanical weathering, one is chemical weathering. When we talk about mechanical weathering, we're talking about breaking things apart, like this iron skillet. My wife actually broke my grandmother's iron skillet somehow by dropping it on concrete, snapped the handle off. Kind of hard to believe. This over here, the rusting of that skillet, is due to chemical weathering, oxidation in this particular case. Chemical weathering changes composition. Mechanical weathering breaks things down by size, not by composition. Okay, that's the first part. So when we talk about chemical weathering, you know about this already. Believe me, you do. Dissolution, we talk about, that's just a fancy word for dissolving things. So we talk about dissolving calcium carbonate, which is calcite, to form caves and sinkholes. We talk about dissolving salt in water, right? So dissolving changes the makeup of things. Oxidation, well, that's rust, for example, where you combine oxygen, particularly with metals, to create new compounds. But one that's not so familiar to you is hydrolysis. And the key thing about hydrolysis is that it is one of the things involved in converting feldspar to clay. So when we talk about the formation of soil, it turns out having clay content is super important. So when the feldspar breaks down into clays, those clays hold moisture and they hold nutrients in place so they don't just drain right on through like they do from sand. So that's why we care about hydrolysis so much. Conversion of feldspar to clay. Mechanical weathering is the breaking down into smaller pieces. So quartz, for example, breaks apart and forms sand mechanically, whereas feldspar weathers in terms of chemical weathering to form clays. Sand and clay together gives you these good loam soils, which Iowa has. Mechanical weathering takes place for a variety of reasons, but the one you're most likely to encounter is that water expands when it freezes. If you ever put a soda in the freezer, you've noticed the can bulging out, right? Well, same thing happens when water freezes in the cracks in rocks. It'll actually split the rock apart. That breaking it down into chunks, into smaller and smaller sizes due to mechanical weathering is what makes quartz really hard into smaller and smaller chunks of sand. We also have biological processes, and they're really important in the soil for breaking down organic material, decomposing it, converting it into forms that we can use for further life. So we've got like mushrooms and decomposers, microorganisms live down in the soils. Sometimes you even see things like trees growing out of rocks, which will gradually break the rocks apart as well. So life converts the rocks into forms that can be used for further life. Pretty amazing. So we would normally sketch this, but I'm going to just tell you a couple of the key ideas. So water moving down through up from the surface is one of the key things for forming a new soil. So when it rains, rainwater is slightly acidic. When it falls on the surface, you got organic material there from leaves and grass and stuff like that, and it picks up additional acids. So you got some acidic water moving down. As it moves down, it dissolves, it leaches out material in the A layer. Then it starts to deposit those things in the B layer, and then further on down it's starting to decompose in the C layer, but you can still see the original rock that it formed. So leaching, depositing, or precipitation is the term, and then down here you have partially decomposed bedrock. That's typical in a humid climate like in Iowa, right? But if you were to go to, say, a tropical climate, surprisingly, like in a rainforest, what you'd find is that the organic layer is really thin. I would expect it to be thick, but it's not. All the things that die decompose really quickly. That monkey that falls out of the tree is almost rotten by the time it hits the ground, right? And so very thin. If you think about the pictures you've seen of trees from the rainforest, they have very shallow roots. They don't go down deep. All the water's up near the surface. They don't have to go deep. But that water then leaches out, dissolves, and converts a very thick A layer. This layer at the top is really thick, and what's left behind is often aluminum and iron. So many of the world's aluminum and iron deposits are found in old rainforest, right? And so that's very thick. So thin O horizon, thin organic layer. If you were to go to a desert, thin organic horizon also. No surprise there, is it? But you don't have very much of a horizon in a desert. You don't have much leaching and dissolution because there's not much water soaking in, right? And what water does go in doesn't go very far into the ground because there's just not much of it. And you get a deposit called caliche, which is kind of like a rock, a layer of cement almost down in the ground that is really hard to dig through because it's all calcium carbonate, that calcite that has dissolved but not been flushed out of the system, so it accumulates to form a layer kind of like that. So thin organic layer in a rainforest, thin organic layer in a desert, but here in Iowa, the humid climate, a nice thick organic layer here. Wonderful soils that we have in Iowa. The climate is just right, enough rainfall, enough temperature, but not too much of either, and so we end up with this nice, great production for corn and soybeans. Okay, so this is a very short sort of lecture. Just remember mechanical and chemical weathering and some biological effects forming these great soils like we have in Iowa, thinner soils in rainforest and in deserts. Hope things are going well. Talk to you guys again